Hi everyone, let's work on some of the CIA review questions together. The first question is asking us to look at these two functions, f and g, and determine the relationship between those two functions. We don't even have to graph these two functions. Even without graphing, we can say what is a relation, because I know that 25 is 5 to the power of x, so g of x could be written as, instead of 25, I write 5 squared to the power of x. Now we know if we have power of power, we multiply the power. So this could be written as 5 to the power of 2x, and we see that this is equal to f of x. So they are equivalent functions. Next question is asking us to determine if the functions are odd degree or even degree. We know that odd degree functions are similar to x to the power of 3, and their end behavior look like this. One goes to the top, the other one goes to the bottom, to two different directions. And even degree functions are similar to x squared, which both end behaviors are going to the same direction. So just looking at the end behavior can help us to find if they're odd degree or even. Like here, one is going down, the other one is going up. So this is an odd degree function. This one is going up, down, so it's odd degree function. But look at these two, they're both going to the same direction, so they are even degree functions. Or even here, they're both going to the bottom, so both go to the same direction, so it's an even function, even degree function. Now let's look at this function. We want to graph this function. It's a rational function. So we need to find the horizontal asymptote here. We know to find the horizontal asymptote, you need to know the degree of the top and degree of the bottom. If the function is not in standard form, that means it's in factored form, we need to find the degree of top and the bottom by finding degree of each factor and then adding them together. Like the first one here, the first factor is x minus 9. The highest degree of this factor is 1. For the second factor, the degree is 1. So you add them. 1 plus 1 is 2. The same is for the bottom. We have two factors. The degree of each of factors is 1. You add them, it's 2. As you see, they equal each other. If they equal, the horizontal asymptote is leading coefficient of top over leading coefficient of the bottom. What is leading coefficient here? To find a leading coefficient, if your function is in factored form, you need to find the coefficient of each factor, the leading coefficient of each factor, which for this one is 1, for this one is 1, and there's another 2 here outside of these two factors, so you multiply them. 2 times 1 times 1. So leading coefficient of top is 2. For the bottom, this factor has leading coefficient of 1. This one is 1. 1 times 1 is 1. So y equal to 2 is the horizontal asymptote. The whole of the function comes from a twin factor on top and the bottom. If you have a factor on top and the bottom, they repeat each other, then we have a whole. But in this case, we don't have anything, so there's no whole. To find the vertical asymptote, we need to set the bottom of the rank equal to 0. Bottom, we have two factors, so you need to set each factor equal to 0 separately. X plus 1 equal to 0, x equal to 1, and x plus 3 equal to 0, x equal to negative 3. Okay, oh, sorry, the first one was x equal to negative 1, and this one is negative 3. So we have two asymptotes here. One is at negative 1 here. The other one is at negative 3. So we have two vertical and one horizontal asymptote. How do we find the 0 of the function? You need to set the top equal to 0. 0 or x-intercept comes from setting the top equal to 0. So I have two factors, set each of them equal to 0. X equal to 9 and x plus 9 equal to 0, x equal to negative 9. So one x-intercept is at 9 and 0. The other one is at negative 9 and 0. What is the y-intercept? You need to set the x equal to 0 for y-intercept. So on this function, wherever I have x, I plug 0 for that. So 2 times 0 minus 9, 0 plus 9 over 0 plus 1, 0 plus 3. Okay, so it's going to be 2. 0 minus 9 is negative 9. 0 plus 9 is 9. 0 plus 1 is 1. 0 plus 3 is 3. If you use your calculator, this is going to be equal to negative 54. So I have a y-intercept down here at negative 54. It's going to be really down. I don't have enough of space, so I'm just going to, let's say this is negative 0 and negative 54, because I don't have a space for that. Okay, so I found x and y-intercepts. I can graph the function. I know that one curve of the graph is going to be on this side because I have 2 points here, so I can graph it right here, passing the x-intercept and the y-intercept here. So this is one curve. The other one is going to be here because it's passing this part of the graph, passing this x-intercept. So this is the other one. However, I don't know what is happening here in between these two asymptotes. I don't know what is that. The easiest way is to graph the function using the calculator. So I can graph it. I can go to my calculator and graph. But another way is to plug in x into function and find what is the y value if x is something between these two. Between these two is negative 2. So I can plug in y equal to negative 2 here, negative 2 minus 9, negative 2 plus 9, negative 2 plus 1, and negative 2 plus 3. If I use my calculator, it's going to be positive 154. So it's a really big number up here. Again, I don't have a space for that. I just assume negative 2 and 154 is somewhere here. Let's say here. So I know that there are asymptotes here. So the graph is going to pass through this point and get close to the asymptote. So it's going to be something like this. But as I said, on your CIA test, you can just use your calculator, enter this into calculator and graph the function, and you will see how it looks like. Anyway, to find the domain of this function, I'm going to move from left to the right and find the discontinuities. As I move from left to the right and see that everything is defined for x values, but I have to make a jump at this x-intercept, which is at negative 3. So I'm going to say negative infinity to negative 3. There is a jump here. There's a discontinuity here. Then from negative 3 to negative 1, because there is another asymptote here, I have to jump at this one as well. And from negative 1, I don't have anything on my way. I can continue moving. Everything is defined after this point. So I write negative 1 to infinity. So this is how you write the domain. Then the end behavior of the function, when x goes to negative infinity, where is f of x or y going? When x goes to negative infinity, that's this side. We know that the x values go to negative infinity on this side. What is y doing? It's getting close to this asymptote, which is at y equal to 2. So I write 2. And on the other side, x goes to positive infinity, y goes to 2 again, gets close to this asymptote. So that's again 2. Next question is asking us to graph this function. 3 times 2 to the power of x plus 1 minus 3. We know that the parent function is y equal to 2 to the power of x. What does the graph look like? We know that if x equal to 0, y is 2 to the power of 0, which is 1. So 1 point is 0 and 1. If x is equal to 1, y will be 2 to the power of 1, which is 2. So 1 and 2, this is the other one. And we know that the graph, this is an exponential function. it looks like this. This is the parent function. It's not this function yet. These are the main points. Now I need to see what transformations I see here. -3 outside of the function moves down 3. +1 is a number added to x. It's going to move the function left 1. And the 3 outside of the function multiplied by the function is a vertical stretch by factor of the 3. Okay, so now I'm going to start graphing my function. First, the points should be moved down 3. So these 2 points could be moved down 3. 1, 2, 3, 1, 2, 3 down here. Then it should be moved left 1. So these 2 points move left 1 and left 1. So far, I just applied the left and down. Next thing is the vertical stretch of 3. So for vertical stretch, I see that between these 2 points, I'm moving 1 to the right and 1 to the up. But when it's a stretch of 3, instead of going 1 up, I have to go 3 up. So it's going to be 1 to the right, 1, 2, 3 up. So the point is going to be here. So one point is here, but then the other one is here because I have moved 3 up. Instead of 1 to 1, I go 1 to 3. Now, also I know that the graph, the original, the parent function, had an asymptote at y equal to 0, but now it's moved down 3. So I have an asymptote here now. And the graph is going to be this. I'm going to use another color. This is the graph of my function that passes through these points, something like this. This question is asking us to list the transformations that is happening to parent function of f of x equal to log x if the f of x is changed to this form. So basically, I can find the transformation looking at these values that are added, subtracted, or multiplied here. I have f of x here. This is f of x. 5 is subtracted from that. So this is going to move down 5. And then 3 is added to the x. This is going to move the function left 3. And a number is multiplied inside the function. So that's going to be horizontal. We know that if it's horizontal, it should be a stretch or compression, but if it's horizontal, always it's going to act opposite. So although the number is less than 1, so it's not going to be stretch, it's going to become, it's not going to be compression, it's going to be stretch. I'm sorry. So this is stretch, although the number is less than 1, by the scale factor of 2, because 0.5 is basically 1/2, but we know that it's going to be act opposite, so the scale factor will be 2/1. So the stretch will be by factor of 2. Okay, next function is asking us to look at this function and find the features of that function. We know that this is a rational function which is transformed. I know that the parent rational function looks like y equal to 1/x. And I see that x is subtracted by 5. That means this is moved to the right 5. And 6 is added to the function outside of the function, so it's up 6. I know that the parent rational function has an asymptote, has a horizontal asymptote at y equal to 0 and a vertical asymptote at x equal to 0. And I know that the graph looks like this. One curve here and another one here. Now this is moved up up 6. So I'm going to move the asymptote up 6. Let's say 6 is here. And the vertical asymptote right 5. So let's say 5 is here. So my horizontal asymptote is now at y equal to 6. It was 0, now it's 6. And vertical asymptote is now at x equal to 5. And this will be the graph of my function now. Okay. Now, what is the domain of the function? Let me erase these extra curves. Domain of the function, I move from left to the right and I see that everything is defined. I just need to jump at x equal to 5. This is the discontinuity. So I write negative infinity to 5, 5 to infinity. For the range, you're moving bottom to top. Everything is defined except at 6. So we have to make a jump here. So you write negative infinity to 6 and 6 to infinity. Horizontal asymptote at y equal to 6. Vertical is at x equal to 5. Decreasing interval, you see that the function is like, I'm going to look at the function, put my pen here. My pen is going down, so it's decreasing. And over here, again, it's going down, always decreasing. The function is always decreasing over the whole domain, which is this. So from negative infinity to 5, it's decreasing. And then from 5 to infinity, again, it's decreasing. So this is the decreasing interval. And it's not increasing at all. Okay, the next question that I want to work on is this one. The free fall speed of an object is modeled by function s of x equal to 2d to the power of 1/2. D is the distance in meters. If the free fall speed is 5.34 meters over second, approximately how far has the object fallen? So here basically this is the speed, so this is s. And it's asking how far has fallen. That's the d value that it's asking us to find. So we're looking for the d. So on this function, instead of s, I'm going to replace 5.34. So the s will be 5.34. And I have 2 times d to the power of 1/2. Now I'm going to solve this for d. The first thing is divide by 2. Okay, so it's going to be 2.67. 5.34 divided by 2 is 2.67 equal to d to the power of 1/2. Next, I want to get rid of the power of 1/2. I can raise to the power of 2. Why? Because if I have power of power, we multiply the power. So 1/2 times 2, they cancel each other and it's equal to 1. So that's how I can get rid of the power of 1/2. So d will be 2.67 to the power of 2, which is equal to 7.1289. For the next question, we see that the height of a rocket after liftoff is modeled by this equation. H equal to negative 16t squared plus 235t plus 4, where h represents the height in feet and t is the time in seconds. And it's asking us, when will the rocket be 99 feet up in the air? So we know that if they basically send a rocket up in the air, it's gonna go something like this, goes up and then comes back down. This is the direction basically of the movement of this rocket. Now it's asking at what point the height is 99. So let's say here the height is 0. When it's 99, it's going up, and let's say at this point the height is 99. But it could be also at this point, because it goes up and then comes back. This point also could be 99. So if I basically draw a line here at y equal to 99, and I know that this function is this. If I could find the intersect point of these two functions, that could be the answer. That's the point of the function that the height is equal to 99. So I'm going to use my calculator. enter the function into y equal the first function, that's the original, and the second one is y equal to 99. Enter that into the function, and then I'm going to graph it. But notice that the window should be really big, because just it makes sense, because we're sending a rocket up in the air. So it's not 1 meter or 2 meters, it's going to be really high. So I defined it as the y mean as -10 and y max as 1000, so I can see the whole graph. The x mean and x max I defined -2 and 50, and I checked it and I saw that I can see the whole graph. So this blue one is basically the rocket which is going up and coming back, and this one, the red one, is y equal to 99. That is telling us where the height is 99. So I go second, trace, and go to intersect, which is number 5, enter. Now it's asking, what is your first curve? I need to see where's my cursor. Okay, so it's asking, where's your first curve? I just enter, put enter, and the curve is here. And then it's asking, where's your second curve? So just press another time the cursor and it's going to go to the right point. And then it's asking, where's your guess? Where do you think is the intersect between those points? I'm going to move the cursor to the first intersect point over here and press enter. So 1 is at 0.4. Then I'm going to look for the second one. I go second, trace, number 5. Then what is your first curve? You just enter, it's automatically going to go to the first curve. And then what is your second curve? Again, enter, it's automatically go to the second curve. And then it's asking, what is your guess? This time I want to move to this intersect point, close to that, enter. So it's 14.27. Okay, so the first one, x was almost 0.4. For the second one, x is 14.2. And we know that by x, basically, we mean the time. So at this time, the height is 99. Also at this time, the height is 99. Okay, so this was some of the CIA review questions. Good luck with your test.